Hi everyone, my name is Grecia and I am the program manager for the digital community at Women Who Code. Today, Madhuri Jakkaraju, software engineer senior manager, and Danthanh Tran, tech and digital product manager at Capital One, will present us the talk, Get Your App Chaos Ready and Go Fail Yourself. Welcome Madhuri and Danthanh, and thank you so much for being here today.
Hi, everyone. Thank you for being here today. Again, I'm Danthanh Tran. I'm a product manager, and MJ and I have collaborated between our teams to do chaos experiments at Capital One. So we're here to talk about how to get your apps chaos ready so that you can go and fail yourself. So this is a chaos engineering talk. So with that being said, let's jump right in. I think that in my lifetime, the biggest chaos experience for me has been this pandemic, and for most of you as well. It completely changed the landscape of internet traffic, but even outside of that, it really truly tested our global infrastructure, going from medicine services to educational services, and of course, workforce. It was truly affected by it. On the left side, these are your productivity tools that were so reliant on the internet that your kids needed it, you needed it to access work. And then along with that, everything globally was running through all of these productivity tools. And then on the right-hand side, because we couldn't go out, we had to spend time at home. And of course, it's the best time to spend time at home is to watch TV, television with your family. And all in the middle is what is now become the modern representation of infrastructure, internet infrastructure. So mostly everyone in the world was reliant on these services. And you know, getting new information became so internet dependent. And I want to focus specifically on educational stats here. But as you all know, I mentioned before, everything else became internet dependent. But by April 2020, so last year, 94% of parents faced a problem where all of their children's schools were closed. And then fast forwarding to the following school year, 39% of incoming freshmen indicated that, you know, they would really prefer to stay at home and take classes online because they were exposed to some of that in the prior school year. And then 30% prefer this hybrid format. I really think the silver lining out of the pandemic, one of the silver linings, is the fact that information became more accessible, education became more accessible. So higher education, you didn't need to be there, but you could take classes from far away. So it's something to keep in mind as we move forward in our industry. So the question, all of us, if you own an application that everyone depends on for very key things, are you prepared for what Murphy throws at you, right? Like you're in the middle of authentication into your workforce and it dies. You're trying to submit a benefits claim and you can't talk to your doctor. And you know, the reality is that 404 errors these days are infrastructure errors because you have configuration issues that you can't that you can't serve, then therefore completely destroys your entire system. And so as service providers, all of us have this obligation to harden our resiliency. Let's take a step back. Chaos engineering wasn't introduced by Netflix, but the Netflix engineering team introduced the concept of chaos monkey. And the idea is that you know things will break. That is just the reality of software. And if you can imagine a group of monkeys coming into your data center, so this is a decade ago, right, into your data center and destroying everything they possibly can, throwing poop everywhere and just clogging up your entire system. And the challenge for IT managers back then was, well, how do I remediate? How do I recover really quickly? Nowadays, we all own our infrastructure. So each and every single one of us has to ask ourselves this question. What are you going to do when that cute little monkey at the bottom right-hand corner just burned down your system, right? And the reaction to all of this is, oh my God, the monkey, such a cool concept. Monkey ninjas are so cool. But you know what? The reality is I'm not going to add that to my backlog at all. Because even both from IT managers, engineering managers, product managers, we couldn't really wrap our heads around how can we recklessly just break our systems like this because you're going to affect the customer experience, right? So it was not really highly adopted by business at all. However, these are the exact reasons why product engineering teams really need to prioritize resiliency testing, chaos engineering. Because just put it in this perspective, you're going from a reactive world where when it happens, for example, if AWS goes down, somebody cuts a Verizon switch, you can't stop the disruption, right? Like, what are you going to do? You're frantically trying to fix the problem, and you're just really, really like, oh my God, it's going to happen. And I hope that all the tabletop exercises we may have done, I don't know, it may work. And so you'd be the Liam Neeson that's begging for the internet to come back. On the other side, if you proactively start disruption, you control it, right? You hit that start disruption, you can stop it anytime you want to. And then you actually have time to assess the failures and then improve. And so the reality is you're not waiting for it to happen because you know it's going to happen. You're going to go and hunt it down and destroy it before it becomes a problem. So I think chaos engineering makes people scared because it's kind of mystifying, right? So what you want to do is go back into your K through 12 where you learned about the scientific method. And before you begin experimenting on any system, you need to know what your baseline is. And so in this 4-step process here, we follow the exact same thing. Chaos engineering is simply experimenting on your system, injecting it with stimuli, recording it, and then trying to improve what the system can do to remediate all the issues. And then 4, and this is where everybody gets hung up on, which is when you repeat it continuously until you're confident enough to promote it to production. You don't go to production on the very first day. And then I think once we wrap our heads around that, we can begin this journey of implementing chaos engineering within our system. And so, as you can see, there are four steps really to the principle of chaos. Highly recommend y'all go read that paper. In our presentation, what we realized is that we spend so much time in the experiment phase, and that's really where it tricks up a lot of people because you don't know how to set up your experiments, and then, oh my gosh, what if something goes wrong? And so in our presentation, we want to focus on steps, experimentation into 2 separate processes, right? And my partner MJ here is gonna take it away and walk us through the process of how she's done it with her team at Capital One.
Thank you, Danthanh. Hello, everyone. I'm Madhuri Jakkaraju, and I usually go by my initials, MJ. I'm a senior manager of software engineering at Capital One and lead engineering teams developing and maintaining critical software systems. Let us now walk through a simple, iterative 5-step approach to practice chaos engineering. 1, form a hypothesis. 2, plan your experiments. 3, run your experiments. 4, interpret the outcomes. And 5, improve and iterate. To demonstrate this approach, let's walk through each step in detail alongside a sample service. Here are more details around the service. Let's assume your team is building a new notification service that sends out a message to a customer when a product is delivered to them. Now, your team is aiming for a 99.9% availability for this service, which technically means you can't have more than 1.5 minutes of downtime. You work with your team to lay out the high-level design and have decided this service is going to be hosted on an ECS cluster. To account for the daily volumes, it needs to have 9 running tasks, and each task is a containerized unit of the service running on an EC2 instance. And all the instances are part of an ASG behind an ALB. Now, let's see what we need to accomplish to get this service chaos ready. First and foremost, it's important to review the application architecture to identify failure points and corresponding customer impact. It also involves understanding the system's steady state and detailing out the upstream and downstream dependencies. Also, list out any recovery procedures that will be needed for your application. This should be a collaborative effort between the tech and product teams to gather both perspectives. Once the assessment is complete, it's going to help group the experiments based on the impact or blast radius. Now, that will help us identify which experiments to target first. Once the assessment is ready, here's how a sample app readiness assessment might look like. So for our notification service, going from left to right, you'll notice we have failure points, retry logic, customer impact, and recovery listed as our assessment attributes. Under failure points, in addition to infrastructure going down, we've also listed downstream dependencies like database or Kafka or Zookeeper nodes going down as potential failure points. This gives us a holistic view of all the failures. Now, you may observe that there's no retry logic around any of these failures. Customer impact varies from message loss, where external customers don't receive a notification, to events loss, wherein internal customers like analysts have missing events for corresponding notifications that were sent out. Highlighted failures self-heal while others don't, and we need to intervene manually to remediate the failures. These would be the ideal experiments to target first. Now that we've hypothesized the steady state, let's proceed to plan our experiment. This step involves researching chaos engineering tools and picking the right tool that suits our needs. Now, you could choose anything that works with you, any internal framework, or several external frameworks that are available and let you do chaos experiments out of box. Then we define our app steady state, programmatically this time, and identify experiments that have a smaller blast radius. You can leverage existing pipelines to have flexibility around scheduling and automating your experiments. Steady state metrics include, but are not limited to, volume, latency, error rate, CPU, memory utilization metrics that are shown here. In addition to these, you can also take into account number of running tasks, min, max, desired instances for your ASG that are not shown on the dashboard here. But you could use several of your existing services to track when these experiments are run. Leverage any existing dashboards that you have or build new ones to monitor these metrics. A big part of this step is to define steady state metrics, which become part of your experiment config that we will see in the later slides. At the end of this step, we're ready to begin experimenting. All right, so as we start running an experiment, we need to monitor metrics in a control phase just prior to the disruption and an experiment phase during the disruption. If you don't have a steady state in control phase, then don't proceed with the disruption, as it could mean there is an underlying issue with the application and you don't want to make it worse. Here are a few tips to execute successful experiments. Run your tests in an incremental fashion, have necessary guardrails in place to prevent accidental triggers, and stop the experiment if you see an unacceptable deviation from steady state. Here's a high-level flow of terminating one EC2 instance for our notification service. On the left-hand side to the dotted line, we have our notification service in a production-like environment. It's not necessarily production. You could think of it as a QA or a pre-prod region with simulated traffic. On the right-hand side, we have our chaos engineering tool and framework set up to run the experiments. Now, here's a sample experiment config.json file for terminating an EC2 instance for the stack or notification service is running on. You'll see that making all the necessary checks, like using an IAM role for triggering the experiments, leveraging steady state probes to validate the state of our app prior to the disruption, helps us execute these in a controlled manner. Scheduling these experiments also helps automate these executions. Now that we have our experiments and the results from both control and experiment phases, it's time to check if the steady state was achieved or it was deviated. You should have all the necessary steps or details that you've gathered from the previous stages or while you were planning the experiments. Now, you could use several metrics that you have been gathering so far to determine your outcome. Now, as such, for the instance termination experiment on our previous step, we should be able to validate if the ASG was configured correctly and if it brought up new instances in a self-healing way. Error rate, latency, CPU memory utilization are some of the metrics that help identify factors that may have resulted in an increased error rate. So once we have gathered these outcomes, we can address the issues and rerun the experiments as needed. Now, you may have noticed, right, like our startup times were high as we recorded the results. Now, the EC2 startup times, well, looking at it, a potential solution you could come up with is adding a custom health check. In addition to the default health check that ALB offers, you could use a custom health check to signal if the additional bootstrapping is complete on your new instance before routing traffic to the instance. Another issue for a high error rate could have been due to instance unavailability. Now, if you're familiar with EC2 events, you may be aware of errors like insufficient CPU utilization, right? How can we overcome that? We could configure min, max, and desired instance values, taking into account how our instances are going to behave when there are few that are actually down. Now, in addition to these above solutions, a design consideration would be to add retry logic in our notification service. So while we take all these resiliency patterns back and incorporate into the experiments itself, we start to gain confidence in running these experiments successfully. We can then move on to increasing the blast radius of the experiments, and then we can graduate from setting up these experiments from test regions to production regions. And to recap, here's our 5-step process again. Form a hypothesis, plan your experiments, run your experiments, interpret the outcomes, improve, and iterate. All right, then. Let the experiments begin. Get ready for the game day. And may the stats be ever in your favor. Thank you for tuning in and listening to our talk. If you want to learn more at Capital One on what technologies we work with or what openings are available, please check out the following resources. And here's a way you can get in touch with either Danthanh or myself. Thanks again.